Hi everybody, today we're going to be talking about linear relationships and how that is connected to slope, y-intercept, and other things like that. So let's get started. Our goal is to compare proportional relationships represented in different ways. We want to be able to interpret y-intercepts on graphs and in real-world situations, and we want to be able to match our graphs to real-world situations and connecting the y-intercepts and the slopes to those. So for our first problem, let's take a look at this equation. Y equals 4.5x. So this can mean all kinds of different things. You could make up your own situation. I'm going to show you the one that I made up for me. So what this would look like in real life. So this situation might look like Miss Allen went to the store to buy a bag of chips. Each bag of chips costs $4.50. Let Y represent the total of cost, so that's how much I would pay, and let X be the number of bags of chips I bought. So if I bought one bag of chips, X would be 1. If I spent $20, then Y would be 20. But we know the bag of chips costs $4.50. Okay, so if I bought one bag of chips, that would be $4.50. If I bought 0 bags of chips, I would have to pay $0. If I bought 3 bags of chips, that would be $13.50. How much would it cost if I bought 2 bags of chips? You can go ahead and use this graph to help you figure out your answer. So if I wanted to look at the graph, I could look here. 1, 2, go all the way up, and it shows 9. That means it would cost $9 to buy 2 bags of chips. The other way you could figure this out is just adding up 4.5 and 4.5. So if I wanted to, I could do 4.5 or $4.50 plus $4.50, and that would give me $9, which is right here. Okay. If I bought 4 bags of chips, how much would that cost? If I looked at my graph, I would look at 4 right here, go all the way up at this point, and it would say $18. So I can look at the graph, or I can take 13.5 and add $4.50. And if I do that, that will add up to $18. Honestly, I don't see myself buying 4 bags of chips, but hey, you never know. Okay, so what does $4.50 represent? That actually represents slope. What is slope? Slope is the same thing as your constant of proportionality, which is the same thing as your rate of change. And it's like, okay, well, what does that mean? Slope, we normally say, is steepness. So how steep something is. Oops. Rate of change is how something is changing. So each time I bought a bag of chips, it was changing by $4.50. Or we call it our constant. We're adding $4.50 each time. It is constant. That number is not changing. Okay. And they all measure how much y is changing over x. So when you compare two things, your y variable always goes on top of your x variable. So your change in y is divided by your change in x. But okay, what does that mean? Let's take a look at an example. If we had a graph and we wanted to find our slope, we would do like we were doing in class, and we would create our triangles. We would take 2 points and we would create a triangle between them. So we would go up, straight up, and then we would come over, and that would create our triangle. Okay. So how tall is this triangle? Okay, this is a height of 96. Okay, and then how long is this triangle from here to here? This has a length of 6. So my rise would be 96, and my run would be 6. And if I simplify those, if I divide, I will get 16. What does that mean for this graph? That means for every cup of flour, I can make 16 cookies, and that stays the same. So 2 cups of flour would be 32, and so on and so on. You would keep adding 16 cookies for every cup of flour. Okay. What if we don't have a graph? What if they give us a table? How would I find my slope then? Okay, so what you would do is you would take your change in your y. So how is y changing? Okay, so we would look. We go from 140 to 224. We know it is increasing. Our number is getting bigger. Okay, but how much is it getting bigger? If you're unsure, just subtract your numbers. What do you get? Okay, let's check. We have to borrow. Oh wait, no, we don't have to borrow there. So straight down. We have to borrow here. And then we get 84. So that means this increased by 84. Okay, now we have to check our change in our x. Okay, our x went from 5 to 8. We also know this increased. How much did this increase by? We can count it on our fingers. 5, 6, 7, 8. So this increased by 3. So if I were to take these two numbers and divide them, I would get 28. And what does that mean for this situation? That means for every acre, there are 28 bushels of wheat. Okay, so we did the graph, which was the triangle. We did the table, which was the change. We saw how much it increased by. The last one we check is an equation. And honestly, I think this is the easiest because you don't have to do much. You're kind of just looking at the equation. So your slope is always the number that is in front of your x, or your variable that's being multiplied. So right here we have our x. So what number is in front of this x? 3. Very good. So 3 is our slope. Over here, what number is in front of our x? 24. Very good. So 24 is our slope. So this one is 24. Oh, 24. Okay, so with a graph, we create our triangles for our rise and our run. For a table, we see how much x is changing and how much y is changing. And for an equation, it's the number that is in front of our variable being multiplied, so x. Okay, let's look at an example comparing all 3 things of these. So we have 3 runners. They are training for a marathon, and one day they all decide to run 10 miles, each at their own constant speed. Which one runs the fastest? So we want to see which one of these people can run the fastest. So what we're going to do is we're going to compare their slopes. So how fast they are running. So let's start with runner number 1. We have a graph. So with our graph, we're going to create our triangle. For our height of our triangle and our length. So we go up for our height, and then we go over for our length. We have our triangle. How tall is this triangle? Good, 20. And how wide is this triangle? 2. It's important to know what these are counting by. So For the height, it was one box. However, that one box represented 20 minutes. So make sure you keep an eye out for that because you don't want to get it wrong. So we have our height of 20, we have our length of 2. We now want to divide those two numbers, and that gives us 10. So that means this person can run 1 mile in 10 minutes. 1 mile in 10 minutes. I mean, that's pretty fast, faster than me, but you guys might be able to run faster than them. Let's check the next person. Okay, they have an equation. So we want the number that's in front of our variable being multiplied. What is the number in front of our x? Good, 9. So this one is not an x, but we could pretend that's an x. Same thing, it's still a variable. So this person can run 1 mile in 9 minutes. Okay, so runner number 2 is already faster than runner number 1. Now let's check the last person. Okay, they have a table. So we want to take a look at the change in y divided by the change in x. So my y would be my time, and my x would be my distance. Okay, so let's take a look. We go from 16 to 32. It got bigger. How much did it increase by? It increased by 16. So 16 plus 16 is 32. So my change in y was 16. Okay, how much did my distance increase by? My distance increased by 2. So I would take those two numbers, 16 divided by 2, and that would give me 8. So runner number 3 can run 1 mile in 8 minutes. So let's compare all of these people. We got runner number 1, which can run in 10 minutes, runner number 2, which can run in 9 minutes, and runner number 3, which can run in 8 minutes. Which person is the fastest? All right, so runner number 3 is the fastest. Yay! Very cool. So even though all of these looked different, we had a graph, we had an equation, and we had a table, we were still able to find out how fast they ran and then which one was the fastest. Okay, so we had talked about this in semester number 1, but I wanted to give you guys a refresher. You might have also learned about this last year. It's the difference between linear and nonlinear. So linear is something that is constant, that creates a straight line when you graph it. Nonlinear is something that does not create a straight line. It can be curved, it can be wavy, it can be like not continuous, so not constant. So if we look at linear, the way I remember is linear starts with a line. So that means we're going to create a straight line. And you see it over here, we got all these straight lines. Very good. Non-linear starts with no line, meaning they don't have a straight line. They're curved. You see how they curve, 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 curve. So curved lines versus straight lines. Linear versus nonlinear. So let's have you practice. You're going to determine if it is linear or nonlinear. So do you think graph number 1 is linear or nonlinear? Do you think graph number 2 is linear or nonlinear? Do you think graph number 3 is linear or nonlinear? Do you think graph number 4 is linear or nonlinear? Do you think graph number 5 is linear or nonlinear? And lastly, do you think 6 is linear or nonlinear? Let's take a look. So this one looks like a straight line. So I would say number 1 is linear. So I'm going to put an L for linear because it creates a straight line. Number 2, also straight line. Oh, mine was not, but number 2 is also linear. Number 3 kind of curves right in the middle. So we would say that's nonlinear. Number 4 is also straight, so linear. Number 5 has a combination of straight, 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 but it's not one straight line. So we would call this non-linear. And then the last one is curved upside down, so we say non-linear. I hope you did good on that one. Okay, let's try another one. So proportional versus non-proportional. Proportional means it's a straight line and it goes through 0. So straight line means it is constant, and then it goes through 0, which means it goes through the origin. So that is proportional. Non-proportional means it is not constant, and it does not go through 0, 0. So does not go through the origin, not constant, and there's a number at the end of the equation. If it's proportional, it's not going to be adding anything because it just goes through 0. So let's practice this one. So proportional or non-proportional? Proportional, I'll write it down right here, means it's a straight line and it goes through the origin. Non-proportional means it's not a straight line and it does not go through the origin. Okay, so number 11, what do you think? Proportional or non-proportional? Number 12, what do you think? Proportional or non-proportional? Number 13, proportional or non-proportional? Number 14? Number 15? And number 16. Okay, let's check. So number 11, it is straight and it does go through the origin. So that is proportional. Number 12, it is straight. However, it does not go through the origin. So that is non-proportional. Does not go through the origin. Non-proportional. This one does go through the origin. However, it's not a straight line. So non-proportional. Ooh, okay, straight line and goes through the origin. This is proportional. And the last one does not go through the origin, so non-proportional. Okay, so let's talk about slopes, vertical intercepts, and graphs. What is a vertical intercept? That is a y-intercept, or that is where you cross the y. So when something intercepts, that means it crosses there, when those two things meet. So if they ask you what is the y-intercept, they're asking you, where does your line cross the y-axis? So if I were to look at the line and the y-axis, if I want to know where these two cross, bam, right there. These cross at 10. So this has a y-intercept of 10. And I could write this as a point as 0, 10 because my y is 10. Okay? So it's your turn. Where do this line and the y-intercept cross? Where is my y-intercept? Okay, so these two cross, these two cross at 200. So my y-intercept would be 200 or 0, 200. Now it says, what does that mean? Okay, well, it says the graph is of a line showing the amount of money paid for a new cell phone and the monthly plan. So we know that they start with 0 months is $200. So before they even start their plan with this company, they have to pay $200. So what do you think that $200 might be? Well, we know that they are paying for a cell phone and the monthly plan. So my guess is that $200 is what they're paying for the phone. And then this is how much they pay every month. So you only have to pay for a phone once, but you have to pay the bill for the phone each month. So it says there's a slope of 50. So to find their slope, they did their height was 100 and their length was 2. So it was $100 for 2 months. And then they simplified that and they said it was $50 for 1 month. So it's asking, what does the slope mean? It means that every month they have to pay $50 for the cell phone bill. Okay, let's take a look at some more graphs. It's saying, is this graph linear? What do you think? Does this graph look like a straight line? Yes or no? Yes, it is a straight line. Now, is it proportional? In order to be proportional, it has to go through the origin. Is it proportional? Yes or no? No, it does not go through the origin, so it is not proportional. And then it says, what is the slope? If I read this, it says Lynn's dad bought a tablet. He pays the same amount each month for a subscription to a movie streaming service. The graph represents how much money he spent for the tablet and the months of the service. The slope is 10. So if we look, it goes up 10 and 1, 10 and 1, 10, 1, 10, 1, 10, 1, 10, 1. So the slope is $10 for every 1 month. And then it says, lastly, what does the y-intercept represent? So it starts at 40, so that means it was $40 for the tablet. And then each month he pays $10. So let's say like Disney Plus. He's paying for Disney Plus $10 each month. And the one-time payment for the $40 of the tablet. Okay. Is this graph linear? Yes or no? Yes, it is. It is a straight line. Is this proportional? Does it go through 0? No, it does not. What is the slope? 5. And then what number is my y-intercept here? 10. That's where it starts. So our y-intercept is where we start, and we started at 10. Okay, one last problem. Lynn has a summer reading assignment. After reading the first 30 pages of the book, she plans to read 40 pages each day until she finishes the book. Lynn makes a graph shown here to track how much the total pages she will read over the next few days. Sketch the line that represents each situation. So how many pages did she read on that first day? 30 pages. So she starts out reading 30 pages. How many pages is she going to read each day after that? 40. So 40 is our slope. because we're going to go up 40 for every 1 day. So if we start here, we're going to go up to 70. And then we're going to go up to 110 for the next day, 110 pages. And then she's going to go up to 150 pages. And then she's going to go up to 190 pages. And then I don't know how big the book is, but let's say she's done there. So we draw this line. Pretend that's a straight line. That shows her pages that she read each day. If we wanted to write this as an equation, it would look like this, where 30 is how many pages she started out with, and 40 is how many pages she read each day after that. All right, so what are our big ideas for today? We want to know that just because a equation can be linear doesn't mean that it has to be proportional. I also want you to know that rate of change is the same thing as slope, which is the same thing as your, there's one more. Oh, constant. Your constant of proportionality. So rate of change is the same thing as your slope, which is the same thing as your constant of proportionality. How do we know if something is proportional or not? It has to be a straight line and it has to go through 0. Slope is how steep something is. Your vertical intercept is the same thing as your y-intercept, and it's where your line matches up with your y-axis. A line is proportional when your y-intercept is 0, so it has to go through the origin 0. So today's goal was to talk about y-intercepts, slopes, and if things are proportional or not, and compare all of that to real-world situations. We did that with the chips, we did that with the runners, and then we did that with the cell phone bills. If you guys have any questions, please email me. Also, feel free to watch this video again if you need additional help. And if you guys need anything else, you can email me. I hope you guys have a great day, and I will see you guys on Wednesday. Bye.